So morning, everybody. While we're waiting for the slides to appear, I'll just point out that I'm presenting this on behalf of the team that did the mission study, which I wasn't involved in, particularly Steve Eckersley and his team at SSTL, but also the team from Oxford. Are we getting the slides? There we are. Yeah, thanks. So talking about LIRIS, which is a mission study to demonstrate how small satellites can really improve the sort of data sets that we have about the moon. So, yeah, so I know you won't all be able to see the detail on that, but this is basically looking at all of the lunar missions since the dawn of the space age. It's reproduced from Scientific American. I'll just point out a few key facts. There was a huge interest in the moon in the early days, particularly driven by the space race. 80 missions in the sort of 60s and 70s. But then Apollo finished in 72. There were a few missions, but then there was a big gap. There were actually no lunar missions at all between 1978 and 1990. Then in the 1990s, we started to get a few missions, particularly Clementine, Prospector, and Smart 1. And then it picked up just over 10 years ago, missions like Braille, Chandrayaan, and so on. But now we see a big interest in the moon. Move on to the next slide. So there's a slow increase in the number of missions, but we're building up to the sort of order of sort of 10 to 20 missions a year over the coming sort of decade. So a big resurgence of interest. Eventually leading to a sustained presence on the moon, human presence on the moon. So looking at what's driving all of this, so the key areas of interest over the next decade, the lunar economy is really being driven by a set of sort of requirements. 3D terrain mapping. Excuse me. Is it possible to get a glass of water? Yes, so 3D terrain mapping is is a very important application area to build better maps of the moon. Multispectral imaging to map the mineralogy and geology and so on. Properties of the regolith, leading to in situ resource utilization, and then looking at the environment around the moon for things like the manned presence on the moon. Moving on. So what can small satellites do? So there's a lot of lunar missions headed towards the surface of the moon, driven by the availability of much better transport systems and so on. So what small satellites can do is really support the infrastructure as one area. So we're looking at things like communications and navigation services. So my own company, Building Lunar Pathfinder, and involved in the ESA Moonlight program, providing comms and nav services. And this presence of an infrastructure makes it much easier to do lunar missions using small satellites. So this allows us to reuse satellite platforms that we've designed for Earth operation in the lunar environment, given that we have a comms and nav infrastructure. Small satellites allow a single focus mission and a much higher tolerance of risk due to the lower costs. And finally, with small satellites, you can build constellations. So here we have SSTL's involvement in lunar missions. So there's actually quite a lot. I won't talk about all of these. I'll point out a few highlights. So about sort of 15 years ago, our first operational lunar mission was Chandrayaan-1, where we supplied the computer that controls the mini SAR payload. And that was quite an important mission because Chandrayaan-1 was the mission that really highlighted the likely presence of water ice on the moon. Following on from that, we did a study called Moonlight, which is different from what you now know as Moonlight. This was Moonlight spelled LITE, which was a science mission with penetrators. After that, we worked with ESA. We did the ESMO study for ESA, which was the student moon orbiter. And in fact, that was key because that led on to Lunar Pathfinder. And in fact, some of the engineers who worked at ESMO are now still working on Lunar Pathfinder. Then Lunar Pathfinder over the last few years, and then in the future, we have Moonlight coming along in the second half of this decade. So on to LIRIS then. So last year, SSTL did an internally funded study looking at how we could do remote sensing around the moon. And around the same time, ESA released the call on the OSIP program for small missions for lunar exploration, which James talked about yesterday in the town hall meeting. So these are highly constrained, cost to completion less than 50 million euros all in for the mission. Has to be innovative for either exploration or science reasons, and needs a fairly rapid schedule. So targeting 4 years from kickoff to launching the mission. So building on the internal study, we proposed to ESA the LIRIS lunar infrared imaging system, which was being developed at the time by SSTL and the University of Oxford. So we put a proposal into the call, and ESA then funded a more detailed study. So what is LIRIS? So it builds on a mission that SSTL's using to observe the Earth. So we built the dark carb system, which forms the basis for the satellite view HotSat mission. So it does medium wave infrared imaging, and you can just see there an image from space of John Lennon Airport in Liverpool. So that's a medium wave infrared. So that's one of the payloads. So it's a variant of that payload. And the second payload is the Lunar Thermal Mapper provided by the University of Oxford. So this is an enhancement of the LTM payload, which we heard about yesterday, which is flying on NASA's Lunar Trailblazer mission. And that does thermal imaging in the shortwave and medium wave infrared bands. So what are the mission objectives of LIRIS? It's looking at the moon and monitoring sort of changes due to the activity, the human activity and the robotic activity on the moon. So we can provide images of the surface areas where there are operations happening. It's finding, characterizing and quantifying resources that other missions might need on the moon, and providing a much improved high resolution mapping of the potential landing sites on the moon. So here we have an overview of the mission and the spacecraft design. So the design was based on a launch happening in 2029, a 1-year mission, a 100-kilometer near polar circular orbit, platform based on the platform we used for the HotSat mission, the two payloads, the SSTL payload and the Oxford payload, total mass around 200 kilos, body-mounted solar panels apart from 2 deployed solar panels, so very similar to Lunar Pathfinder, which you'll see on the poster over there if you want to see how that looks. Making use of the infrastructure, so making use of ESA's Moonlight system for data communication services. And it's basically an Earth observation satellite, which is modified to take account of the fact it's in a different environment. So we have to move to a thruster-based AOCS system because we can't use a magnetic field to do momentum dumping. We have bigger power and thermal fluctuations, so we have to design that into the platform. And the mission profile, the mission analysis is quite different with eclipses. The end of life scenario is very different to Earth and so on. But it's basically a modified Earth observation platform. So moving on to the conclusions. The availability of the infrastructure that's being built around the moon makes it much simpler to do missions like LIRIS. They can be developed in a low-cost way. The baseline platform that we've used for this mission, the CARB Plus platform, could host other payloads. So we've looked at an infrared payload here, but we could put hyperspectral, multispectral images on there. The thing we're looking at now, actually, which is also interesting, is how we could take the sort of platforms we're designing for the moon and then use them around Mars. So obviously that's yet again a different environment, particularly the impact the distance from the sun has on your power system is probably something that causes the biggest change on the platform. But we are interested in looking at Mars as well as the moon now for low cost missions based on small satellites. And I think that's the end of the talk. Yeah, so thank you for your attention. And yeah, I can try and answer questions, but as I say, I didn't do any of the work on this, so it might be a bit tricky. Yeah, no. Oh, we got one. I was about to say few, no questions, but there we go.
I'll just say it out loud. What are the next steps? It's on now. What are the next steps for LIRIS? You said it was a study for ESA. Is there another gate in front of it before it moves to a commissioned mission?
Well, as James mentioned yesterday, there was a huge number of mission ideas presented into the OSIC program, and ESA's done a down select to 2. So we aren't one of the 2. So we obviously we're a bit upset about that, but we'd like feedback from ESA. We can look at other ways we could get this funded, and or we could look at what ESA didn't like about it and maybe submit it into a sort of future call with a slightly different sort of payload suite. So at the moment, it's on ice at the moment, but we hope to be able to rejuvenate it at some point.